and welcome to another Paper Classroom 5-minute video. Today we're talking another theoretical aspect of drying. This time we're talking about the 3 stages of drying. So these are the classic curves. The blue curve represents the evaporation rate of water. So the evaporation rate increases, the evaporation is constant, the evaporation rate declines. And the red dotted line represents the sheet temperature. So here the sheet temperature starts to rise, the sheet temperature is fairly constant, and then the sheet temperature rises again. So there are 3 distinct areas there. These bottom cylinders here represent progress of the sheet through the drying section. So these 3 sections we're going to look at in detail one by one. First of all, first stage, increasing rate of evaporation. It's what you'd expect. You put a cold sheet onto the first 2 or 3 drying cylinders and the sheet gets warmer and warmer. As the sheet gets warmer and warmer, then there's more energy in the water and therefore the rate of evaporation of the water will increase. That's exactly as we would expect. So the sheet heats up, and the hotter it gets, the greater the rate of evaporation. If we now move on to the second stage, interesting, constant rate of evaporation. The sheet is at constant temperature, and that's why we have a constant rate of evaporation. So evaporation rate is proportional to temperature. The big question is, why is the sheet at constant temperature? Now stop the video for a moment, have a little think about it, and when you've decided what your answer is, then restart this video and I'll tell you what you should be thinking. Okay, welcome back. What it is, the reason why the temperature is constant is because it is impossible for it to go any higher. The sheet is saturated with water through this region. Because it's saturated with water, you cannot get the sheet above 100 degrees C, which is the boiling point of water. So therefore, if you're at maximum temperature and it's constant, then the evaporation rate will be constant. And you'll see a little extension of that, a little bit more about that in this third phase now. So, the third stage of drying. Here we see the evaporation rate is falling, and here we see the sheet temperature is rising, and this point where the 2 curves intersect is known as the critical point. So, why is the rate of evaporation falling? It's falling because there's no more water left to be evaporated, therefore the evaporation rate must fall. What we're seeing then is the sheet temperature is rising. Why is the sheet temperature rising? Because the water is no longer there to hold the temperature down, and therefore it can rise. And how hot could it go? Well, it could actually reach, if you were on a different system, if you were on maybe a through-air dry system or an air flotation dry system, you could actually reach 451 degrees Fahrenheit, which is approximately 233 degrees C. And those numbers are important because that's the spontaneous combustion temperature of cellulose. So if you are in the right sort of drying environment with the paper, if you do exceed these temperatures, then you might expect the sheets to spontaneously combust, and then you'll have a little fire. And it's not unusual in certain mills, certain industries, for that to happen. So, a quick summary of 3 stages of drying. First of all, in the first stage we have an increasing rate of evaporation. In the middle area we have a constant rate of evaporation. In the final area, the third stage, we have a falling rate of evaporation. And something else to remember, the critical point, that's the point where water can no longer hold back the temperature of the sheet. Okay, thank you for listening to this video, and I hope you will follow us on any of this social media. Thank you.